Okay, this clip we're going to show you how to calculate turbulent kinetic energy. The turbulent kinetic energy is commonly denoted as K, and it's equal to a half times the square of the fluctuating components in the x, y and z directions added together. So in the x direction it's u dash squared, in the y direction it's v dash squared, and in the z direction it's w dash squared. So that would capture the turbulent kinetic energy for any flow. However, it's quite commonly assumed that the fluctuations are the same in all directions, so we can sort of perhaps treat the flow as isotropic turbulence. This isn't true near the wall, but in the free stream we can assume that the fluctuations are the same in all directions, so it's quite common to say the turbulent kinetic energy is 1.5 times u dash squared. Let's do an example of this then. Let's say we've got a flow with a turbulence intensity equal to 0.5%, and what that means is that the fluctuating components, RMS, divided by the mean flow is 0.5%. Let's use the example. The mean flow is at 120 meters per second, and we want to work out the turbulent kinetic energy for that. So we can start off by just working out the u dash RMS, and that is going to equal the intensity times by u bar. So that's 0.5% times by 120 meters per second, which gives us a u dash RMS of 0.6 of a meter per second. So in this flow of 120 meters, average mean flow of 120 meters per second, we've got a fluctuation plus or minus 0.6 of a meter per second root mean squared, so an averaged fluctuation. Okay, so we assume it's isotropic, so the turbulent kinetic energy in this example then is 1.5 times by 0.6 squared. So we end up with a turbulent kinetic energy of 0.54, and it's meters squared per second squared. So that's a short example of how to work out the turbulent kinetic energy of a flow.